بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.9 and it's about related rates. So what is the idea of related rates problems? Well, we compute the rate of change of one quantity in terms of the other rate of change of another quantity. That's the idea, and that's why they are, it is called related. So let us see some examples. Air is being pumped into a spherical balloon. So there is a balloon and the air is pumped into the balloon. What happens when you pump air into the balloon? A lot of things are changing. The volume of the balloon is changing. If we call the volume of the balloon V, then he says here that the volume increases at a rate of 100 centimeter cube per S. So what is the meaning of this? Increases at a rate of, and it changes, the volume changes with respect to what? When you pump the air, the volume changes with respect to time per second. Centimeter cube is the unit of the volume. So 100 volume per time, per second. Unit of volume over unit of time. Rate. What is the rate of change? It is the derivative. So when he says that the volume increases at a rate of 100 centimeter cube per S, he means that dV by dt is 100 centimeter cube per second. So each second, the volume increases by 100 centimeter cube. So rate means derivative. So dV by dt, the derivative of the volume with respect to t is 100. Okay, so it's constant. The derivative here is constant. It's not changing. After each second, the volume will increase with 100. How fast is the radius of the balloon increasing or changing? Air is pumped, so also the radius is changing. But he is asking about the change of the radius. So if we call the radius r, then the question is asking about dr by dt. What is dr by dt? And if he just asks about dr by dt, it would be maybe a variable, the answer. But he said, how fast is the radius of the balloon increasing when the diameter is 50? Well, if this is a circle, okay, this is the diameter. The diameter is the line passes by the center, okay? This is the diameter. And this is the radius. From here to here, from the center to here is the radius. So the diameter is 2r, 2 times radius. So if 2r is 50, then the radius is 25. And the question, how fast is the radius increasing? So what is dr by dt when r is 25? So that's the question. So in this example, dv by dt is given, and dr by dt when r equals 25 is required. Good. How to solve the question? We need an equation that relates the volume by to r, to the radius. This is a sphere, spherical balloon. So what is the volume of the sphere? Well, the volume of the sphere given by 4 over 3 pi r to the power 3. So that's a known formula. Volume of the sphere is 4 over 3 pi times r cube, where V is the volume of the sphere and r is the radius of the sphere. Good. So now we have a formula or an equation that relates R to V. But we need dr by dt, dv by dt. So how to find dv by dt, dr by dt? We find the derivative of this equation. We derive this equation with respect to t. So v, the volume, is a function of time. Time changes, volume changes. R is a function of time, radius. Each second, the balloon, the air is pumped and the radius is changing with respect to time. So the derivative of v would be dv by dt or v prime, okay, equals. Now 4 over 3 pi is just a constant. We don't do anything with the constant. When it's multiplied by a function, we keep it. And r to the power 3, we find the derivative of r to the power 3. It's 3r squared times what? Times r prime or dr by dt using chain rule. Okay, so here this what happens when we find the derivative of this equation with respect to t. Now dv by dt is given. It's 100 in the question. So this is 100 equals 4 pi. 3 cancels with 3. Okay. 4 pi times r square. What is r? R is 25. He said find dr by dt when r is 25. And dr by dt is wanted, is unknown. So solve this equation for dr by dt. How? We divide 100 over 4 times pi times 25 square. So 4 times 25 would be 100. So the answer would be 1 over 25 pi. So this is dr by dt, change of radius with respect to time, centimeter per second. Because dv by dt centimeter cube, so dr by dt would be centimeter by second. This is the idea always, okay? We have dv by dt, dr by dt. We try to find equation that relates them, and then we solve for the unknown. Another example. A ladder 5 meter long rests against a vertical wall. So let us assume that this is a vertical wall and this is a ladder that rests against this wall, and there is a distance here between the bottom of the ladder and the uh, the wall. Okay, so this is the wall, this is the top of the ladder, this is the bottom of the ladder. The ladder is 5 meter long, so the length of the ladder is 5 meter. Rests against a vertical wall. Okay, if the bottom of the ladder, this one, slides away, it starts moving away from the wall. All right. So what is changing here? If we call the distance between the bottom of the ladder and the wall x, then x is changing. Okay. When the ladder is here, this is the distance. If the ladder starts moving to this point, then x would be all of this distance. If the ladder moves up to here, then x would be all of this distance because this would be the bottom and x is the distance from the bottom to the wall. So x here is changing with respect to what? With respect to time. Okay, x is changing. Do we know dx by dt? Do we have dx by dt, change of x with respect to time? He said what? At a rate of 1 meter per second. So this is dx by dt. Every second it increases by 1 meter. Increases. Okay, the distance increases because the ladder goes away from the wall. All right. That's why it's positive because it's x is increasing. How fast is the top of the ladder sliding down? Now, when the ladder moves to this direction, the top of the ladder will go down, okay, and sliding down, okay. So if we call the distance from the top of the ladder to the ground, if we call it y, then this y is changing every second. If the top of the ladder is coming down, okay, sliding down, then y is changing. All right. And he is asking about dy by dt. He did not give us dy by dt. He is asking about it. How fast is the top of the ladder sliding down? When the bottom of the ladder, he has always to give you at. So he's not asking about the derivative. No, the derivative at some value. So at what? When the bottom of the ladder, which is this point, is 3 meters from the wall. What is the distance from the bottom to the wall? Yeah, x. So he says when x equals to 3. So find dy by dt when x equals to 3. Good. So we have x and we have y. These are the two variables in the problem. We need an equation that relates the two variables. Well, we can use Pythagorean theorem. Pythagorean theorem says x squared plus y squared equals 5 squared or 25. Good. We have the equation. We start finding the derivative with respect to time, to t. So derivative of x squared is 2x times dx by dt using chain rule. Derivative of y squared is 2y times dy by dt. Derivative of 25 is 0 because it's just a constant. Good. What do we have? We have x is 3. So I can cancel 2, divide by 2. Okay. X is 3 times dx by dt, which is 1, plus y. Well, I need to find dy by dt. But what is y? I cannot have two unknowns in the equation. So y must be known. There must be a way to find y. Well, he said find dy by dt when x is 3. Okay. So when x is 3 and the hypotenuse is 5, can I find y? Yeah, use Pythagorean theorem. Y would be square root of 25 minus 9, which is 16. Square root of 16 is 4. So y would be 4. When x is 3, y would be 4. And dy by dt is unknown. Solve this equation for dy by dt. 3, take it to the other side and divide by 4. So dy by dt is negative 3 over 4 meter per second. Why it's negative? Because y is decreasing. The distance from the top of the ladder to the ground is decreasing because the top is sliding down. So when the variable is increasing, the derivative is positive. The variable decreasing, the derivative is negative. Another question. So this is the steps we do. Okay, we read the problem carefully. We draw a diagram if possible. We introduce notations, assign symbols x, y to the quantities that are functions of time. So all the quantities usually in the problem are functions of time. And then we express the given information, usually d something by dt, dx by dt, or dy by dt, and the required rate in terms of derivatives. Okay, so the information and the required usually are rates, so derivatives. And then we write an equation that relates the various quantities of the problem. And then we use the chain rule to differentiate both sides of the equation, and we substitute and we solve for the unknown. These are the steps exactly which we followed in the previous two questions. And let us follow it now also in all the questions. Example 3. A water tank has the shape of an inverted circular cone. This is a circular cone, and if it is inverted, it would be like this. Okay, this is an inverted circular cone. Circular because the base is a circle. Okay, with base radius 2 meter. So the distance from here to here, that's the radius of the cone, and it is 2 meter. The radius is 2 meter, the radius of the cone. And the height of the cone, the distance from here to here, is the height. That's 4 meter. Okay, so the distance is fixed. The distance, the cone is not changing. The cone is fixed. Its radius is 2, its height is 4. Now what's happening if water is being pumped into the tank? So we will fill the tank with water. Okay. Now, what is changing with respect to time when you fill the tank with water? The level of the water. Okay. Assume that after 1 or 2 seconds, the water now is here, filling this, okay, this part. So the level of the water is changing with respect to time. This distance, which is the level of the water, let us call it h, height of the water, okay? H, height of the water, it's changing with respect to time. This distance, the radius, okay? The radius of the water, I mean the cone when it's filled by water, this distance, it is also changing with respect to time when the water increases. And the volume of the water is changing with respect to time. These are the quantities that are changing, and these are the quantities that are fixed. Here in the warning, he said you have to understand in the question which quantities are fixed and which quantities are changing. Okay, so what's happening? Water is being pumped into the tank at a rate of 2 meter cube per minute. Meter cube, this is what? This is the volume. Per minute, this is time. So what is this? This is dv by dt. dv by dt is 2, increasing. This is the volume of the water. Okay, changing the rate of change of the volume of the water. The volume of the cone is not changing. Find the rate at which the water level is rising. So he needs the rate of what? Of h, the height of the water. When the water is 3 meter deep, so when h is 3. So that's usually the case. We have one rate and the other rate we asked about. Now, what should we do? We need a relation equation between V and H. V is the volume of the water and H is the volume of the water. Well, this small cone, okay, we know that, or there is an equation that relates the volume. The volume of the cone is 1 over 3, okay, r square times h. Of course, 1 over 3 1 over 3, 1 over 3 pi, yeah? There is a pi, r square h. You can remember this formula easily because the cone is 1/3 of the cylinder, and the volume of the cylinder is the area of the base, which is a circle, and the area of the base is pi r square times the height, which is h. Okay, so if this is r, this is the volume of the cylinder. The cone is 1/3 of a cylinder, so the volume of the cone is 1 over 3 pi r square h. I'll erase this so you don't confuse uh, because we are talking about cone here, not cylinder. But look to the formula, look to the equation. I have V, R, and H, three variables. And these three variables are changing with respect to time. The radius of the water is changing, H, the height of the water is changing, the volume of the water is changing. But in the question, he gave me dV by dt and he asked about dH by dt. So I know nothing about dr by dt. So if I find the derivative now of this equation, there would be dr by dt, and I know nothing about dr by dt. So what should I do? Well, I should remove r from this equation. I should write it in terms of one of the other variables. Do you understand this? So how to do that? Look to this carefully. Now, this 2, which is the radius of the cone, is fixed. It doesn't change. And the height of the cone is 4 and it doesn't change. This is the cone. Now for the water, I have the water is here. Assume that the water is here, this level. So now this distance is r and this distance is h. And r is changing and h is changing. These two triangles are similar, the black one and the red one. Two similar triangles. This is R, this is H, and the black one, 2 and 4. So what do you know about similar triangles? If we have two similar triangles, for example, this is triangle, okay, and this is another triangle, similar. What is the meaning of similar? All the angles are equal. I mean the angles in this triangle and in this triangle. So this angle is equal to this angle and this angle is equal to this angle. It doesn't have to be like this. I mean, this one is similar to this one if all the angles are the same. So all the angles are the same. So the two triangles are similar. What do we get from this? That if this length of this side is A, and here B and here C, and here this one, the corresponding one, let us call it A dash, and this is B dash and this is C dash, then A over A dash would be equal to B over B dash would be equal to C over C dash, or A dash over A equals B dash over B, whatever uh, is correct. What does it mean? It means that the length of the sides are proportional. So here in these two triangles, look to these triangles, the black and the red, I can write 2 over r, this side over this side, is equal to 4 over h. Or if you want, r over 2 is h over 4. Okay? And then you solve this equation for r, because you want to get rid of r. So what would be r? Multiply by 2. So 2h over 4, or r is h over 2. So in this case, r is h over 2. But this is not a fixed relation. This is because the radius of the cone is 2 and the height is 4. All right. So now I can come to this equation and write it 1 over 3 pi and replace r by h over 2. So v would be pi over 3. This is h square over 4 times h. So v would be pi over 12 h to the power 3. And now this equation is nice because it relates v and h only. I can find the derivative with respect to t. dv by dt equals, this is a constant, keep it as it is, and find the derivative of h cubed, which is 3h squared times dh by dt. So what is dv by dt? It's given in the question, it's 2. Now 3 over 12 divide, so pi over 4, 12 over 3 is 4, times h squared. What is h? It's given in the question, it's 3. So h squared would be 9. dh by dt is unknown. We need to find it. We need to solve this equation for it. So simply dh by dt would be, I have 2 here. Now I have 9 pi in the numerator, so they will go down here, okay, because I will divide by them. 4 in the denominator, so it will go up in the other side because I will multiply by 4. So the answer is 8 over 9 pi watt meter per per minute. So this is the answer. How fast, the rate at which the water level is rising when the water is 3 meters deep. The last example would be car A is traveling west. So there is car here and it's traveling west in this direction at 80 kilometer per hour. What is this? If we call this distance x, the distance that car A is traveling, then this x is changing with respect to time. Each hour it increases by 80 kilometers. So what do we have in the question? We have dx by dt. This is given. Car B is traveling north. This is car B at 100 kilometer per hour. So if we call this distance y, the distance that car B is traveling, so we also have dy by dt. It's 100 kilometer per hour. Both are headed for the intersection of the two roads. There is no intersection here, so this is not correct. This graph is not correct because both cars are headed for the intersection. So the intersection is here, x is going like this, so y actually, or car B, is coming here. So this is y, not this one. So this is car A traveling west. This is car B traveling north, and they headed for the intersection of the two roads. So this is the road, and this is the road, and this is the intersection. They are heading to the intersection. Now the distance between them when they are here, this is the distance between them. Let us call it Z. Now when car A is moving and car B is moving, this distance is changing. X is changing, Y is changing, and Z is changing. All of these variables are changing with respect to time. Okay, good. At what rate are the cars approaching each other? Of course, Z is decreasing, it's not increasing, okay, because the distance decreasing until they approach each other. So at what rate they are approaching each other? So this means he is asking about dz by dt. What is the rate of change of z, the distance between the two cars with respect to time? What when car A is zero point 0.3 kilometer, this means what? That x is zero point 0.3 kilometer from the intersection, and B, so x is the distance between A and the intersection, and y, the distance between car B and the intersection. So when y is, or B, car B is zero point 0.4 kilometer from the intersection. So that's the question. What is dz by dt when x is zero point 0.3 and y is zero point 0.4? So what are the variables in the question? Z, x, and y. These are the variables. Well, I need a relation between these three variables. Well, using Pythagorean theorem, x squared plus y squared equals z squared. Notice here that Z is changing. It is not like the ladder question. The ladder wasn't changing. Okay, good. The derivative, find the derivative. 2x with respect to t, dx by dt plus 2y dy by dt equals 2z dz by dt. I can divide by 2, so I can get rid of all the 2's. Okay, what do we have? Well, I have x is zero point 0.3. I have dx by dt, it is 80. I have y, it is zero point 0.4. I have dy by dt, it's 100. I do not have z, and I do not have dz by dt. Actually, dz by dt is required. So I have to find z. Z must be given. Where? How to find z? Well, he said x is zero point 0.3. So when x is zero point 0.3 and y is zero point 0.4, what would be z at that instant, at that time? Okay, so I use the calculator. What is the Pythagorean theorem says? It says that z is square root of zero point 0.3 square plus zero point 0.4 square. So find the square root of zero point 0.3 square plus zero point 0.4 square. The answer is zero point 0.5. So z is zero point 0.5 times dz by dt. You have one unknown now, so find dz by dt. Let me multiply zero point 0.3 by 80. This is 24. 0.4 by 100. This is just 40 equals half. Zero point 0.5, or just half dz by dt. So dz by dt would be multiply by 2. So 24 plus 40 is just 64. Multiply by 2, that's 128. So dz by dt, the 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 distance between the two cars is changing with by, this is the rate. The rate of change is 128 kilometer per hour at that instant. That's the end of this section, and I hope that uh, it seems that there is a mistake here. Let me, yeah, what is the mistake? There is an, of course, Z should be decreasing, isn't it? But it's positive. but I did not, yeah, I forgot that also x here, when a approaches the intersection, is decreasing. So in fact, dx by dt is not 80. If you forget the minus sign, everything will be false. And y is also decreasing because the car is moving, b is moving towards the intersection. So y is decreasing, it should be negative 100. X is decreasing, it should be negative 80. So here, this should be negative 80 and this should be negative 100. So this is negative 24 and this is negative 40. And then, all right, yeah, uh, point, let me check of this one too. Point 0.3 square plus zero point 0.4 square under the root. Yeah, it's zero point 0.5. So we have negative 24 minus 40. Yeah, he said, yeah, it's okay. So negative 24 minus 40 and multiplied by negative 64 multiplied by 2. So it would be negative 128. So that's the answer, just the negative sign. Thank you very much. Hope you understand now the related rates. And when you put increasing, when you have increase, when the length is increasing, you put positive. When it's decreasing, you put negative.